Biofouling is the attachment of organisms to submerged surfaces, such as ship hulls, underwater instruments, and marine or freshwater platforms. In this video, we will examine why biofouling is problematic, the factors that influence biofouling, and then we will finish with a few innovative engineering solutions to the problem. The cost to the shipping industry associated with biofouling is in the billions of dollars. Biofouling of ships results in increased hydrodynamic friction, leading to higher ship drag and subsequently higher fuel requirements. More fuel consumption results in higher carbon dioxide emissions and more harm to the environment. Furthermore, as ships go around the world, biofouling can result in the introduction of non-native species to new environments, which leads to the rise of invasive species. Time and time again, invasive species have been shown to be detrimental to ecosystems. Biofouling can also initiate and facilitate the corrosion of metals, thereby increasing the probability of structural failure. The performance of an underwater marine instrument can be also negatively affected by biofouling because of the increased weight, and sometimes living organisms can interfere with the normal functioning of sensors. For all these reasons, biofouling is very much an economic and an environmental problem. There are several thousand organisms that engage in biofouling. These include, but are not limited to, barnacles, zebra mussels, tube worms, mollusks, microorganisms, plants, and algae. According to the International Maritime Organization, IMO, biofouling begins within hours of ships being placed in water. Biofouling depends on the design and construction of the ship. In other words, a ship with a large number of niche areas, such as hull appendages and protrusions, may have more fouling. Another factor that contributes to biofouling is the specific operating profile, which may entail operating speed and location of ship when not in use, whether it's in an estuarine port or open anchorage. The form of the ship maintenance is also a factor, in that the type of anti-fouling agent used and hull cleaning practices affect fouling. So, what can be done about biofouling? This problem presents an environmental engineering challenge. The traditional engineering approach was to use the toxicity of metallic compounds to reduce or limit biofouling. The metallic compounds can be oxides, such as cuprous oxide, or organometals like tributyltin, TBT. Cuprous oxide and TBT were added to paints that were used on ship hulls. However, a ban was placed on the use of TBT after it was discovered that this chemical was bad for the environment, in that it is toxic to a variety of organisms, such as marine mammals and fish that are not involved in biofouling. TBT is detrimental to fish, as it interferes with liver metabolism, causes tail abnormalities, and leads to a slower development rate that is concentration dependent. Hence, other anti-fouling agents have been sought out. The use of non-toxic coatings, such as silicone coating and fluoropolymers, prevent or minimize biofouling to an extent. Also, ultrasonic transducers are effective in small and medium-sized boats. It has also been demonstrated that the use of plasma pulse technology is effective against zebra mussels. All relevant links to materials used to make this video are in the description below. Please don't forget to like, subscribe, and return next week for more engaging videos. I post videos just like this every Thursday for environmental scientists and engineers, and for anyone who's interested in the environment. Thanks for watching. Cheers!